Good morning all. Today we are going to understand semaphore and operating system. Before understanding semaphore, you must understand process synchronization. So what is process synchronization? Process synchronization means we can understand it by that a processor has to run multiple processes at a time. So operating system has to manage all the processes so that they can run properly and do not interfere each other. So for that purpose process synchronization is required. So for doing this process synchronization, semaphore technique is used. So in operating system, semaphore is most important technique for with the help of this we can operating system can synchronize processes. So semaphore is a synchronization primitive used to control accesses to a shared resources in a concurrent system such as an operating system. Means when there are multiple processes are running, so processes are sharing some resources. So semaphore is a technique to synchronize all the process so that shared resources can used properly. It also helps to prevent race conditions and ensures that processes do not interfere with each other when accessing shared resources. Means when there are multiple processes, they are running and they are sharing some resources, so processes do not interfere to other process. So to ensure that semaphore is used. Semaphore is of two types, counting semaphore and binary semaphore. So counting semaphore can take any integer value and it is useful for managing a limited number of identical resources. And when we are having same resources, number of same resources, limited number, so then we can use counting semaphore. For example, a semaphore for managing access to a pool of 5 printers. There are 5 printers in our system. So semaphore is managing 5 printers by counting semaphore. And second one is binary semaphore. It takes two values, 1 and 0. So what is, we can say, mutex. So what actually binary semaphore is do? It acts as a lock to control access to a critical section. Means both the processes do not enter in the same time to share a resource. So at that time binary semaphore is used. It can take two values, 0 and 1, and it is used in mutual exclusion and shared memory access. Now we understand semaphore operations. First operation is wait operation, which is known as down operation and it denoted by P. Second is signal, it is called up operation and it is denoted by V. Wait operation means, as this name suggests, wait means when one resource is occupied by one process, then wait operation takes place. And as soon as one process occupy resource, then it decreases the value of semaphore. Means if semaphore variable value is decreases by 1, that means one process is occupying one resource. And semaphore variable is having value less than 0 or 0, it means that no resources are available for processes. So when new process wants some resource, so it should wait because resources are already occupied by one process. So when wait operation takes place, we just understand that process has to wait till resource gets free. So as soon as one process occupies one resource, it decreases the value of semaphore. And when it increases the value of semaphore, signal operation. Signal operation increases the value of semaphore means as soon as one process releases the resource, it gets increased semaphore value. Means when process release the resource, the value of semaphore is increased by 1. So this operation is also known as signal. Means signal is the signal for the processes that resources are available. We can link this by this. Wait means process has to wait because resources are not available, already occupied some process. And signal is what do you understand? Signal means you can enter. That means if there is signal operation takes place, means some resources are freed by processes, means resources are available for some new process. So these are two types of operations which take place by semaphore. We can see some examples of semaphore. That one scenario what we understand is when there is single printer, and single printer should be managed by operating system. So at this time operating system use binary semaphore. When initial semaphore value is 1 because there is only one printer which is available. So process 1 is getting wait operation. Wait operation means semaphore value becomes 0 because initial value of semaphore is 1, and when one process gets occupied printer resource, then semaphore value becomes 0. And what happened for process 2? Process 2, when request for process, it checks the value of semaphore is getting 0, so process 2 is blocked. Means for process 2 there is no resource available. And what happened next? Process 1, when process 1 finishes its operation, it applies signal operation and value of semaphore becomes 1. And now operating system can give the printer to the process 2. Okay. And that was one scenario example of semaphore. And problem which is critical section problem, and when operating system use semaphore in critical section problem. When multiple processes needs to access shared resources, only one process should access the resource at a time to avoid inconsistent results. Semaphores can be used to solve this problem by enforcing mutual exclusion. Example, if two processes try to write to the same file simultaneously, semaphore will prevent this by blocking access to the file during the operation. Means when two processes are there and they want to write in the same file, so it will create confusion if both the process gets entered at the same time to the file. So semaphore will prevent one process and lock another process, and when one process did its job completed, then only semaphore give permission to the next process to share the same file. Use cases of semaphore. Use cases when operating system can use semaphore in following use cases. First one is mutual exclusion, which is also called mutex. Protect critical sections of code to ensure only one process accesses them at a time. Second is reducer consumer problem. Semaphores can be used to synchronize the production and consumption of items in a shared buffer. Reader-writer problem. Multiple processes can access a shared resources simultaneously, but if a writer is writing, no reader should be allowed access. Means when something is written on some file, at that time no reader is allowed to read that file. So this is reader-writer problem. In this problem semaphore is used. And deadlock prevention. Semaphore can be used to avoid deadlocks by carefully ordering resources request. This is the use of semaphore. Advantage is this: efficiency, flexibility, and prevents race conditions. Efficiency means semaphore are a lightweight mechanism for synchronization, making them efficient in terms of system resources. So efficiency of operating system gets increased by semaphore. Flexibility, they can be used to solve a variety of synchronization problems such as mutual exclusion, bounded buffer problems, etc. And third is prevents race conditions. Semaphores help to prevent processes from interfering with one another in a multi-threaded environment. And there are some limitations of semaphores. It can lead to deadlock risk. If not used carefully, semaphore can cause deadlocks when processes wait for each other indefinitely. And complexity is also there. Semaphore management can become complex, especially in large systems with many processes. And third is priority inversion. Low priority processes might hold a semaphore needed by high priority process, leading to inefficiency. So it is some limitations of semaphore. And one producer consumer problem is there, and it is solved by semaphore. Problem is, a producer produces items and a consumer consumes them from a shared buffer. The buffer has a limited size, and synchronization is needed to ensure that the producer does not produce when the buffer is full and that the consumer does not consume when the buffer is empty. This is one problem, and it can be solved by semaphore. What it use a mutex semaphore to protect the buffer, and use empty and full semaphore to keep track of the available space and items in the buffer. Conclusion is, semaphores are a critical synchronization tool for managing access to shared resources in concurrent systems. They are essential for solving problems such as mutual exclusion, deadlock prevention, and the producer-consumer problem. And key takeaways are, there are two main types of semaphores: binary, which is mutex, and counting semaphore. Counting semaphore is also use one integer value. Semaphore operations are to wait and signal, allow processes to coordinate efficiently and safely. And that's all. Thank you so much.